Okay, hello everyone. This is going to be a recording of our talk, or my talk, on contributing to PyKX, which was live streamed yesterday as of me recording this. But we had some technical issues, so I'm coming here to set everything straight, and we'll have something nice because, like I said before, we had some issues. So let's begin. I am Oscar Niza. I am a computer engineer that's working as a software developer at Habla Computing. I've been doing so for well over 2 years. I think it was about 2.5 years, something like that. And today, and yesterday, I wanted to talk to you about contributing to PyKX and our experience with it, because we have done a single contribution that's already been merged, and there's another one that's going to be reviewed. So it's in review as far as we know. So we wanted to share this experience with you and hopefully encourage any of you viewers to make your own contributions. So what about me? As I mentioned before, I've been working at Habla Computing for the past 2.5 years, and I've mainly done so at the BBVA. And in there, I've used technologies such as Spark, and then later on KDB. With Spark, I did some migrations and then some process maintenance. And when we moved to KDB, I was involved in a project that wanted to migrate a Python and pandas code base over to KDB and Q. With that, I gained some experience with those technologies, and I managed to put that into a couple of contributions. One on PyKX. Of course, it wasn't only mine. There were a couple of functions developed by other colleagues of mine. And then, of course, I've done a bit of work on Quercus, the library that Jesus presented on the last event. And apart from that, I've been writing some blog posts on Ablabs blog, so that's blog.ablabs.com. And there's 3 of them that have to do with KDB. The first 2 of them, all roads lead to PyKX and KDB. I was a co-author, and it set the ground for we wanted to lay a step-by-step guide on how to migrate from a pandas and Python environment over to Q, going over PyKX. Then I explore KX dashboards on a short post. And finally, we have contributing to PyKX, which is a very nice complement to this talk if you're interested. So if anything sounds interesting to you, feel free to drop by our blog and take a look at those. Let's start. So my goals for today are going to be, first off, introduce you to PyKX. So we'll talk about what it is, some things that we are able to do with it. We'll talk about the Pandas API, and then we'll move on to the contribution lifecycle. And we'll start by identifying some contributing opportunities. So we'll try to run some functions. We'll locate some of them, only one of them for this talk, that is not really implemented on PyKX, and then we'll code it, test it. It will not be as simple as that, so we'll have to go back to patching this function, and then we'll go into some other aspects of this contribution. So let's switch to a Jupyter notebook, and I'm going to start the introduction to PyKX. So the first thing that we should be asking is, what is PyKX? And it's a library, a Python library that's developed by the KX team. And it was open sourced, I think it was about May of last year, so that's 2023. It aims to bridge the gap between Python and Q. By providing an interface in both languages to interact with the other language. So for example, we have regular PyKX, which is a Python library that gives us the ability to run Q code. And then we have its counterpart, which is PyKX.q, and that enables us to run Python code inside Q, which could be really useful for, say, for example, machine learning workflows, right? So, what's the first thing that you should be doing? Well, first off, you should be importing PyKX, and that's done with this command right here, just as anything in Python. And this object right here, this KX object, contains a bunch of methods, one of them being this Q1. And this method actually wants to receive a string as its first parameter, and anything that's inside that string will be executed on a Q session, and its results will come back to us, will be sent back to us as a Python object. So it will be wrapped around the Python object. So in this case, of course, if inside the string we place some Q code, it will get run. So in order to generate a 10-element list, we can do so like this. And in this case, we get a PyKX long vector, and this is the content of this is the content of it. We can see that we actually get the result that we are expecting, but wrapped around this construct, this PyKX long vector construct. Yeah, so that's something really interesting, because it enables us to interact with these objects from Python. But that's out of the scope for this talk, so let's move on. Next up is toQ, and this method allows us to convert Python objects, or some Python objects, of course not all of them, to Q. And in this example, I'm going to convert this very simple dictionary back to a Q1. So in order to do that, you just plug it into this kx.toQ, and if I print this, if I run this snippet of code, we can see that it gets wrapped in this object, so it's a PyKX dictionary. We can see that as that. And the contents of it, well, they look very much like a Q dictionary. So nothing new here if you are familiar with Q. Just know that you can interact with this dictionary from Python. Another cool thing that I've grown to appreciate is the ability to use Python standard library, no, not really standard library, but Python objects as parameters for Q functions, right? So say, for example, that you have something like this, which is a list of lists, each one of them being a different length, and you wanted to count the number of elements of each one of them. And you know that in Q it's really simple. You can do a count each, simple stuff, but you are really familiar with Q, but you don't know that much Python, so you would want to leverage Q's speed. And for that, PyKX comes to the rescue, and that's because it enables us to run once again Q code, but we can pass in a parameter to it, right? So in this case, we are passing our list of lists, and in turn, this will be, I'm guessing right here, but it will be run in a toQ method, so that it's converted to a PyKX object, and then it will run in as a parameter for this function, and it will be returned to us. Okay, so the result will be returned to us, and then that result, then since I'm using this method right here, it will return all the way back to Q. So we are going full circle. Okay, so if I do this, we can see that we get 2, 3, and 1 as a result, as a Python list. Next up, what is the Pandas API, right? The Pandas API is a part of a part of the PyKX library that aims to provide some a drop-in replacement for pandas functions in PyKX. Okay, so say for example that you had a full pandas workflow and you wanted to migrate that to PyKX to leverage the speed advantages that you may be getting. So first thing you need to do in that case is, well, get your data into a PyKX table, for example, and then thanks to the pandas API, if everything goes smoothly, you shouldn't need to do much else, because like I mentioned before, the pandas API wants to provide you with the same syntax that pandas does. So just to provide you with an example, say we have a data frame that looks like this. So it's a person, age, and height data frame. And in pandas, we wanted to calculate the average of the age, the average age and height of our users. And in order to do that, we need to pass in this parameter, which basically strips out this person column. So if we had a date, it would get stripped out. It just returns the numeric only subtable. Okay. So if we do this, then we get a sort of dictionary with the average age and the average height. Okay. Next up, we could do something like this, like what is found on this cell, which is basically flipping the axis. And what this does is that instead of calculating the average over the columns, it will calculate it over the rows. Okay, so in this case, it doesn't really make that much sense, but it will be calculating the average between each person's age and height. Okay, so if I run this, we can see that we get our result, and in this case the dictionary keys will be the index rows, right? So 0 all the way through 4. Okay. Thankfully, thanks to the pandas API, we can do exactly the same and get the exact same results. So if I run this to queue method with my data frame, I should be able to convert it into a PyKX table. And sure enough, this looks like a queue table, so we should be good. And if I run this, notice that the syntax is exactly the same one as in pandas. If I run this, well, we get the same result as we did before, a sort of dictionary with the average age and height. And in this case, well, we get the exact same thing. Okay, so say that you had to perform another operation, in this case the standard deviation, with this DDoF parameter. We'll get into what this means later on. And you wanted to calculate that over your data frame. So if I run this, we do just fine. Remember, this is in pandas. And we get, once again, a sort of dictionary right here. Okay. If I run this with the same syntax on PyKX, well, we should be running into an error. The table object has no attribute std, as in standard deviation. And what this basically tells us is that PyKX doesn't have this function available. So now we have something to work on. It's a function that it will prove not only useful to us, but could be useful to many people. So instead of writing an internal function, something that's going to be used only for our team, I would encourage you to, instead of doing that, just making a contribution to the library. And thankfully you can find this walkthrough of help. It can help you with that task. So yeah, we'll be coding this function, and then we'll be testing it and seeing if everything comes as expected in the end. Okay, so first thing that you should do is, well, explore pandas' implementation of the standard deviation, because, well, if the pandas API aims to provide a drop-in replacement, well, the interface should be really similar. So it should accept the same parameters, and it should give out, or should I say, it should return the same kind of output. So let's explore it. Let's see what this snippet of code does. So say we have this list, and in order to run the standard deviation in pandas' way, we need to turn it into a series. And if you are not familiar with pandas, don't think too hard about this. This is just a fancy list, okay, which has some methods available. So we can run the standard deviation function with this parameter right here, the DDoF of 0 and the DDoF of 1, okay? And if I do this, if I run this, we can see that we get two different results. So the DDoF seems to be very important for the actual computation. At this point, you need to think, okay, what do I have available in Q? What's available to calculate the standard deviation on Q? And the first thing that should come to mind is both def and sdef, those two functions. And well, what happens if I run this with the very same list? What happens if I run these two functions? Well, surprise, surprise, we get that def gives out exactly the same result as the standard deviation with DDoF 0, and sdef does the same thing as standard deviation with DDoF 1. Okay, so that's all good, that's all right. But what if we wanted to run something like this? A DDoF 2, 3, 4, something like that. That returns this result right here, but we don't have this available in Q. We can't really specify the DDoF parameter, right? So we need to dig a bit deeper. And if you dig deep enough, you'll find that Pandas uses NumPy internally, and NumPy implements the standard deviation as this formula right here, okay? Notice the denominator part, where n is the number of occurrences, and the DDoF is, well, the DDoF parameter. This will come into play later on. And by the way, DDoF stands for delta degrees of freedom. For those of you who may be into maths, you may already know what this means. But yeah, as I mentioned before, this is a bit out of scope, so let's continue. Since there's nothing really all that interesting to this formula, we can just come here and implement it in Q. And yeah, nothing worth mentioning here. This is just a translation of this formula into the language. So you may be able to notice that we have two parameters in this function, one of them being the DDoF, the second one is the actual list, and well, we can pass in a custom DDoF and then make a projection and then apply that projection to our list. So if I do this, we get DDoF 0, 141, which is well, maybe expected, maybe not. If I do DDoF 1, we get 158, which looks similar to sdef. And if I do DDoF 2, well, we get 182, which is the exact same result we got from Pandas, okay? So we have arrived to a general implementation of the standard deviation, but I would encourage you to think a bit deeper than this, to strive for more. And one thing that you may be thinking at this moment is, okay, how do I improve the performance of this function? And one thing that we can do is reuse def and sdef, because, well, those functions have been well tested. We know that they work, and we know that they will most likely be faster than our own implementation. So in this case, what we're going to be doing is creating a function that given a DDoF, if that's equal to 0, it returns the def function. If it's equal to 1, it returns the sdef function, and otherwise we will return our custom implementation. So in this case, well, we can do something like this, and we get the standard deviation with DDoF 1, DDoF 2, same thing, and we have a more general function and a bit more performant than before, okay? So this is going to be the core of our function. This is going to be the core of our implementation, our contribution. Now what we need to think about is how do we bring this into PyKX? How do we make it available as a PyKX table function, method? And in order to do that, I'm going to switch to the slides once again, and I'm going to move on to the coding section right here. But before anything, you need to make sure that, well, first off, you need to fork KX Systems PyKX repository. This is available on GitHub. And that's because, well, you need to have permissions to push your branches. And I'm pretty sure that you will not be able to do that on KX's repository. After that, of course, clone the repository and follow the setup instructions just so that you have the correct environment. You need to create a feature branch and then locate this file right here, pandas-meta.py. And that's located in the source directory /PyKX /pandas API. And there's a bunch of functions right here. And I'm pretty convinced that if you place your function, the standard deviation function, anywhere in these files, you may be able to get away with it. But since, well, there's a specific order right here, we wouldn't really want to place it anywhere. So for example, say if you were to be working on a custom join, you will place it in this merge file, pandas merge. If you were to be working on a filtering function, something to do with where, then you would do that in this indexing file. But I mean, with our function, it's a bit more general. It's a general computation, so we can place it on the pandas meta. That's the logic behind where we placed it. And inside this file, what I would recommend you to do is to, well, take a look at the whole file, see how it's structured and how things are done generally, and then locate some similar functions to the one that you want to implement. So you take into consideration the interface once again, and then see how things are done, right? In our case, we located two very similar functions. Those were mean and median, and the reason that they are very similar to what we want to accomplish with our standard deviation function is because, well, they have very similar parameters. We already saw that mean accepts the axis and numeric only parameters, but median does so as well. And the outputs of both of these functions is actually very similar. It's a sort of dictionary which will contain the columns, for example, the column names as the keys, and then the actual value of the computation as a value from on the dictionary. So these two are very similar to what we want to accomplish on the standard deviation. We studied both of them and we saw that there were some common steps that were in both of them. So for example, how they dealt with key tables. Of course, you need to think that the table that you may be calling this standard deviation method on might be keyed. And well, how do you handle that, you know? And the best thing right here is to, like I mentioned before, study how that's being handled on other functions and then bring it to your own function. So we'll see how this is done in a second. Then it handles the numeric only parameter. Once again, take a peek at another function, see how this is handled, bring it to your function. Then you modify the table depending on the axis parameter, and maybe modify isn't really the best word to describe that, but we'll see how this is done, like I mentioned, in a second. And then after that, we perform the computation. So this is our code. I'm going to explain everything in a minute. It looks like a lot, but hopefully it will be clear at the end of these slides. But first off, I need to build the library. And since it's going to take a couple of minutes, I'm going to go ahead and build it right now. And in the meantime, we'll come back to the slides and I'll explain everything. And hopefully by the end, the library will be built. Okay, so let me switch to my terminal right here. And if I do something like this, well, actually, first off, I need to make sure that my code is available on this file. As you can see, right here I have the mean and median functions, and well, I have it right here. This is the code that you just saw. This is a quick spoiler, sorry about that. This is the code that you just saw on these slides. So make sure that the file is saved on disk, and then come here and run the pip install. Okay, so like I mentioned, this is going to take a couple of minutes. We'll come back to this in a second. In the meantime, let's see what the function is doing. So the first thing that we need to take a look at is the parameters. And first off, it accepts the self parameters and this parameter, and this is going to be the table itself. we are working with object-oriented programming in this case. Then we have the axis by default 0, we have the delta degrees of freedom parameter by default 1, numeric only set as false by default. Okay, so this is going to be our front-facing interface. Then we deal with the key tables, and this is the way that we detect that. And then if that's the case, if that turns out to be true, then we need to get the value out of it. And if you were to be, if you wanted to run something like this in Q, if you wanted to do something like this, you would use value, the value function, and you can access that function with this syntax right here. This q.value may seem a bit strange, but this is just kx.q.value. Okay, so this is just running value on the table. After this, well, we need to handle the numeric only parameter, and for that we have this handle little function that the PyKX team already coded. So it's available on this file, and it's been used so much that, well, they made it into a function. So what this does is, well, if we have a string column and a date column and two numeric columns, it will strip out these non-numeric columns and return the subtable that contains these numeric only columns. Okay, maybe a bit redundant on my side, but yeah, I hopefully explained that well enough. After that, well, we need to get the table keys, and by that I mean if you think about the output, well, we are going to be returning a dictionary, right? So what are the keys of that dictionary? Depending on the axis, if that axis parameter is equal to 0, the dictionary keys will be the column names. Okay. However, if we have axis 1, the dictionary keys will be the index, the row index, you know, so 0 all the way to the end of the table. So this line right here takes care of that. And then after that, right here on this line, we take care of the values, because of course, if we are operating column wise, we want to just extract the values out of the table. But if we want to operate row wise, we want to flip them. So that's what's been done here. And at this point, this tab variable contains a list of lists. That's just raw data. Okay. You should be able to recognize this. This is our Q function. There's nothing really of interest here that we haven't mentioned before, just that it isn't really on a function anymore. It's just a conditional, and that's stored in this d variable. After that, we need to build a dictionary, and well, we have these access keys already calculated, and then we run the d function for each one of the values of the table. The table right here is the list of lists. And hopefully by this point, the library should be successfully installed, and we can see that this is a development version. So if I come back to my notebook and restart the kernel right here, I should be able to import the this development version of PyKX. Okay, so if I do this, we get the very same data frame that we were working with earlier. We bring it into Q, so we are importing and then bringing the table to PyKX, and then run the standard deviation on pandas, and then on PyKX, and we can see that voila, we get the same result. Cool stuff right here. So now that we've tested this, it's time to run the tests, and for that, well, I've already gone ahead and wrote a bunch of them, but I'm going to be explaining the basics of it. Okay, so what do we need to do in order to test our function? Well, for those of you who may not be familiar with this testing, well, we are going to be using Python, and what we want to test for is actually just regular use, so just standard deviation without any parameters on a table that we have control over. Then we need to test all possible parameter combinations. So we have the numeric only parameter and the axis one. Of course, DDoF also comes into play. And then test some edge cases. And the testing itself is going to well, this function, this custom function that we built, is going to be tested against the result returned for pandas' implementation. So we'll be creating a data frame, bring it into PyKX, then run a function, this standard deviation function on both of them, and compare the result. Okay. As for the test file, well, it's located in this directory. We have this tests directory in the root of the project, and inside that we have all of the tests for the project. For example, if you were to be working on some IPC stuff, you place your tests inside this IPC directory. If you were to be writing some pandas tests, well, you have a bunch of functions, files. Once again, place it wherever your similar functions are. Okay. So in order to run our tests, we are going to be running this command right here, and just it's worth noting that we are going to be running only our test, and we'll see in a second how those tests look like. Okay, but we'll need to specify the file name and the test name itself. So let me go into the code once again, and I have this file open right here. And well, if I scroll up a bit, we'll land into the min tests, and in this case, well, we can see that we have a test function for each function. So right here we can see that, well, it's doing what I described a minute ago. Creates a data frame, brings it into PyKX, runs the function on both of them, and checks for the result equality. Okay. So as I mentioned, I've already created some tests, and you can see that there's a bunch of them right here. But yeah, I'm going to be running them, and we'll see if we have any issues. Okay, so if I run, I think it was Python 3.10 in my case, PyTest, and then I do this. Yes, that's our function. If I run this, it should, well, we'll see the result in a second. This takes a couple of seconds. And yeah, we get an assertion error in this line right here. We can see that it is at the beginning of the tests. So here's the first assertion, and that's okay. We have no issues with that. But at this point, it's failing because, well, we have a DDoF of 4. Okay, our data frame has 4 entries, 4 rows, so that's interesting. Same DDoF as number of elements. And it's checking for some null values, right? So in this case, we are making sure that we get a null from the pandas result, and we get a null as a result of the PyKX computation. Okay, so we are getting one of those in our pandas one, but not on PyKX's side. So let's go into our notebook once again, and let's try this once more. Okay, and you can start to see the issue right here. So our data frame had 5 entries. Okay, so we are going to be running with DDoF of 5 in this case, and we can see that pandas is returning not a number, so a sort of null value, and PyKX instead is returning a infinite value, right? So a positive infinite value. And we can start the debate over which one of them is more correct. In my opinion, PyKX's result is better, but since we are trying to stay as close as possible to pandas' interface, we need to make sure that in this specific edge case, we return a null. Okay, so let's go into the slides and start thinking about the patch. And well, we need to take that specific case into consideration, and I've already done that, of course. Once again, these are the only 2 lines that are going to come into play here, but since I have to rebuild the library, I'm going to switch back to my terminal, and well, first off, before the terminal, we need to make sure that we have the changes on the code. And this is what it looks like. Let me save my file, come back to the terminal, and right here I should be able to install my patch. Okay, once again, this is going to take a couple of minutes, so we'll come back to this in a second. So this is what it looks like, and well, we are checking for if the delta degrees of freedom is equal to the length of the table. And notice something really cool in this line is that we are using Python's standard functions with PyKX objects, something that's worth mentioning. If that's the case, then we create a dictionary full of nulls. Okay, so we have the access keys, which will be the dictionary keys, and then we fill that dictionary with nulls. And since this is the whole explanation and it has taken a couple of seconds only, the build is still going on. So I'll move on to some other aspects of this contribution. And once I finish this, the build should be done, and we'll see if the tests pass, which, trust me, they will. So before creating the pull request, well, you need to make sure that you have three things. You need to have the code, you need to have the tests, and you need to have the documentation. And the documentation, as for the Pandas API functions, goes into this Pandas API notebook, right? So once again, we have based our implementation on mean and median. We've based our tests on mean and median, so our documentation should be no different. We should be looking for those for how those two functions are documented and based our own on that. Okay. After that, you need to run all tests available on the project. This command right here is very similar to the one that we used before, but just notice that we are not specifying the file and test itself. Okay, so we are running all the tests inside the tests directory. I'm not going to do this because it takes like 40 minutes on my machine, so just yeah, something that's worth taking into consideration. After that, you also need to make sure that you are following the styling guidelines, and to make sure that you are doing that, you need to run this command, pflake 8. You can install it, it's available on pip, I think. And if you do this, it will make sure to tell you where you, for example, this line is too long, you know, you've gone overboard with the number of characters. For example, if you are missing some white spaces on some operators, they will make sure to notify you. After that, as for the PR itself, well, you need to open an issue using the template that's available. You need to open the pull request itself using the template that's also available and link it to the issue. And that's just to make sure that, well, once the pull request is merged, the issue gets closed. You also need to assign both of them to yourself, tag the developers, and await the review. Okay, and that's pretty much it. But before moving into the conclusion, I think that the build should be done. Yes, successfully installed this development version once again. So let's quickly check the fix on the notebook before running the test. So let me restart the kernel. And if I'm able to run this, you should be familiar with this code, so nothing new to mention here, just that we are running this function, our own function, on PyKX's function with DDoF of 5. Okay, so if I do this right now, we'll see that we get a null, and if I run the tests right here, they should be all right. Give it a couple of seconds, and yeah, there we go. That's it. We're good to go. Now we should move on to documenting and opening the pull request and everything that we've just talked about. So as for the conclusion, well, what have we got out of this? Well, by doing this contribution, we've learned a couple of things. First off, that the standard deviation function, it's not really all that customizable or flexible in Q. So if we wanted to run a standard deviation with a DDoF of 5, for example, we would need to implement that function ourselves. Also, we've learned some things about Python library development, which is something that personally to me was really interesting. And we got a taste of open source, you know. We got some satisfaction from, well, contributing to a useful library that that's part of KX's ecosystem. And by doing that, in my case, what I enjoy about this the most is that, well, I'm not the only one that's going to be using this code, and there's some people that might find it really useful down the line. Also, of course, you become a part of a community of developers. The community of open source is huge, as you may know. It's always growing, so it's great to be a part of that. And finally, well, feel free to improve on our implementation. Since it's open source, if you find anything that's wrong with it, well, you can just submit your patch to it, get it reviewed by the PyKX team, and yeah, hopefully it will get merged. So yeah, that's great stuff right there. Of course, also thanks to Connor and and the PyKX team for all of the help that they've given us. And I'm pretty sure that if any of you have some issues with PyKX development, if you reach out to them, they will be very glad to help you. So yeah, thank you very much for taking a peek at this talk. Hopefully it wasn't too inconvenient yesterday, and hope you got something out of this.